Hello and welcome to Learning Kyma. My name is Christian Lechner and today we are in the first episode, and what we will do is we will set up our Kyma cluster and make a little walk through the different areas that are then available when you have set up your cluster. Now, starting point is our SAP Cloud Platform Trial account. As we said in episode 0, this is something that you should have prepared. And I'm logged in my account here, and now I enter my trial account. From the global account, I navigate down to my trial account. And after that, what we will see here now in the overview section is we have the Cloud Foundry environment, which is there. And we have another environment, that's the Kyma environment. It's there, but it's not enabled by default. Now, maybe you do not see this section when you start. Then you have to check your entitlements that are on the left-hand side in the entitlement area, which basically says if your sub-account is entitled to use Kyma. You can then do a search within your entitlements. So let's see, when I search, I see, okay, there is a sub-account assignment. If this is not the case in your sub-account, you have to configure your entitlements. So you have to add a service plan, search for Kyma, which I will do now in my case. Then you see the Kyma runtime, and here for me it's grayed out because it's available. You have to tick the box in order to activate the plan for your trial, and then add the service plan. And as soon as this has happened, the Kyma section will be available. Now, enabling Kyma is just one click away, basically. We push the button of enabling Kyma, which will lead us to a pop-up. We leave the cluster name with the cryptical area. We put in the description like learning Kyma. So I type that in now just to show you that's completely free text, and then we create the cluster. And just one remark, this will take some time. So we hit the button and then the creation of the cluster is kicked off. And now you can basically go and grab a big cup of coffee. Okay, so after quite some time has passed, the Kyma environment is deployed. Now, just a pro tip, if you want to start learning Kyma, kick off the creation of the environment at some point in time, for example in the evening before you go to bed, and then you can start the next day, because it's really, it takes some time and it makes no sense to wait. Now, if the Kyma environment is up and running, the first thing you would like to do is you want to go to the dashboard. Now, you switch to the dashboard, and now what you see is you have not enough permissions. And well, that's true, because there is one thing missing within your setup, and that's the roles in the Kyma environment that you need to be assigned to in order to access this dashboard and in order to work with Kyma. So let's create a role collection that has the roles, and then assign that role collection to us. So I have opened up here the help.sap.com area, where the getting started description is for Kyma, and there are two predefined roles. We have the Kyma namespace admin, and we have the Kyma runtime namespace developer. We will assign us the admin role. I will also show you how to design the developer role. We will need the admin role because we will do a lot of stuff, so the developer role will not be sufficient. However, even with the admin role, there are some restrictions concerning add-on configurations and the Kyma system namespace that we will see throughout of the course when we try to access resources or create specific resources. Now, back to creating a role collection. So we want Kyma roles admin. Let's call it that way. So all Kyma roles needed. So we create this role collection, and then we navigate to the role collection and we edit it. So we assign the Kyma roles there. Let's see, does this work? No. Kyma runtime namespace admin. So as you see, there are these two predefined roles. We have the Kyma runtime namespace. How is it called? Kyma runtime namespace developer. Let's copy it. And let's see if we find it. Yeah. What was my typo? I don't know. So these are the two roles that you have. Yeah, the admin role is sufficient. Nevertheless, here you see that. And then we can assign. So we saved that. I sometimes have some issues with saving here. Now we have to assign a user. We can do that here via user ID, or we can also switch over or switch back to our trial and go to the trust configuration. So here we have our IDP. So that's kind of a different way how to assign roles. That's especially feasible if you want to assign multiple roles or collections. I will type in my email address of this account, and then I will assign role collections. Here I go to Kyma roles admin, assign the role collection, and now we should be fine. So let's go back to the overview. Let's open the dashboard, and ta-da, here we go. Okay, so now I'll make it a bit bigger. Here we are within the Kyma overview area, kind of the dashboard for your Kyma cluster. And what you have seen is the opening of the dashboard is super fast. Let's do it again. So compared to like refreshing this page, it refreshes the page perhaps at some point in time. It's loading, then you have these three dots. Takes some time, right? I open the dashboard, bam, and it's there. Now, why is that? The reason for that is, if we take a look what's behind here, this dashboard, we see something that's called Luigi. So let's see what this is. We'll take a look at Luigi SAP. So this is a very specific micro front-end JavaScript framework that is especially targeted for creating administrative user interfaces. And this framework is used for all the Kyma UIs that you are accessing when you administer Kyma. And that's also the reason why it's fast like hell. just as some additional info if you are interested in that. Okay, so how are these things structured now? So we have the Kyma dashboard, okay. We have our icon, which tells us something about our preferences. We can log out and we can get the kube config. Okay, this is something that I will go into next session because there we will then work with this kube config. But it's important to know the kube config is located here behind your icon. Now we have namespaces. What are namespaces? This is a concept that has nothing to do with SAP Cloud Platform. We have seen within the SAP Cloud Platform, if I switch back, we have this concept of a global account, then we have this sub-account thingy. And if we go to Cloud Foundry, we have the Cloud Foundry specific areas, which are organizations and spaces that allow you to structure your environment. And in Kyma, we have namespaces. Now, what's the secret behind that? So let's dive a bit into the architecture of Kubernetes. I have stolen some pictures from the official Kubernetes site that will explain you what's behind this namespace thingy. So basically, how is a Kubernetes cluster that's lying underneath Kyma structured? So first of all, we have the cluster per se, which is really a cluster in the sense of I have resources coupled together, I have compute power coupled together within one cluster, and that is physical or running on a virtualization or whatsoever. But this is really the hardware, the compute power that is available for you within your overall Kubernetes cluster. Okay. Then within this Kubernetes cluster, we have different artifacts. So what do we have? We have this master process, or this master area that is responsible for managing your complete environment within Kubernetes, within your Kubernetes cluster. So this is the boss. This is responsible for all the orchestration stuff and so on and so forth. And what's important for us as developers are these node processes, and these nodes, these other stuff that's depicted here. And the nodes, well, they are the workers. They are the little pieces within Kubernetes that do the work when you start your application, when you scale your application, and so on and so forth. The master distributes the resources, the nodes do the work. Within the nodes, we have so-called node processes. So every node has a specific set of processes, which is the kubelet and Docker process. And the kubelet is responsible basically as a unified interface so that the master can talk to the nodes and vice versa. Now, what's lying within the node? So we have the cluster as the base layer. Then within the cluster, we have this master. I don't know if it will be renamed concerning this discussion around master-slave things. And then we have the nodes that do the work. Within the nodes, we have, let's say, the atoms of Kubernetes. These are the things where the magic happens. These are the things where basically your apps are running, and that are the pods. So we have the cluster. Within the cluster, we have the nodes. And within the nodes, we have one or multiple pods. And as you see here, every pod has an IP address and is addressable via the kubelet running in the node process. Now, what's important, or what's often a misunderstanding is what's running now within the pods. Is a pod a container, or can there be several containers within a pod? And this picture already kind of gives you a hint that I want to show you here. A pod can contain one container, it can contain several containers, and it can contain so-called volumes, which are kind of amounts of persistent storage that will not be lost when your pod dies. Because Kubernetes does one thing. You tell Kubernetes how many pods you want to have for an application. So with respect to redundancy and keeping things running. And maybe a pod dies for what reason whatsoever. Then Kubernetes will spin up another pod. Now, if you put your database per se within a pod, when the pod dies, the database basically goes away. That's the file system within the pod will also vanish. And this is where volumes come into play, which hook up or abstract the persistency that it will not go away, and that is available from all the pods. Now, however, it's important to understand a pod can contain one container, a pod can contain many containers. So it's not a one-to-one relationship. Each pod can be different. Now, we did not yet come across the topic of namespaces. Now, what is a namespace? Now, let's go back here and let's think a bit. So if you want to do development and we develop microservices, we will probably have a node, several nodes. Within the nodes, we will have several pods running. And we will have a development area, we have a staging area, we might have a productive area. Now, how do we structure that? How is the best way to structure that if you would only have one cluster and nodes within it? Do we name the nodes the right way? And this is where the concept of namespaces comes into play. Namespaces are nothing more and nothing less than virtual clusters. So on top of this physical cluster that you see here, we define namespaces, which are virtual clusters, which are kind of gated areas where you can structure your development, where you can structure your projects, your applications. And within these virtual clusters, you then have your nodes running and you have your apps running. These namespaces then provide you a defined scope with respect to names. So when you name resources that are running within your namespace, they have to be unique within one namespace, but not across namespaces. And what's also important about namespaces, you cannot nest namespaces. So you cannot build a stack of namespaces. So you have your Kubernetes cluster, then you have the namespace, and that's it. You cannot embed a namespace within a namespace. That's not possible. And with these namespaces, you can now kind of divide your cluster according to your requirements. Okay. So and when creating a namespace, when creating a Kyma cluster, you get one namespace, and that's the default namespace. We have no pods. You remember pods? These are the things that contain the containers. That's okay. We have no bound applications, so we have basically nothing hooked to this namespace. Okay, that's fine. We understand that. Then we have two more topics here. That's integration. Probably has something to do with integrating other systems here. You don't have any application yet. That's right. So this seems of kind of a global way how to hook up systems to your Kyma system. When we remember the idea about Kyma, it was extending systems, it was extending applications. So I guess This is where the integration part comes into play. And then we have diagnostics. Okay, and that's the logs. So let's see, what do we have here? We can select labels. We see, so here we have nuts. If you remember the episode, the very first episode, nuts was something about messaging. There's nothing about streaming. There's nothing here. So let's see. There is something going on behind the scenes. There is some logging, some aggregated logging of your Kyma cluster represented here with auto refresh. Okay, that's cool. And the labels, well, labels is a construct within Kubernetes. It's a very important construct. You can assign labels to each and every resource. It's basically just a name value pair or a map. And you can with labels, you can structure your resources in a very generic way. So there is no fixed definition on how you want to aggregate things within Kubernetes, and you can use labels for that. So that's a very, very powerful construct. And this is something when you set up your development, you should think about how you want to label things. That's from my perspective important. Do it in a grow as you go manner. But prepare kind of a landing zone for your first application where you define a basic, let's say, governance. And one part of that, from my perspective, are labels. Okay, so that's it here. Now let's see, let's go on. Let's move to the namespace. As you saw, super fast. So you have an overview within the namespace. We are now within the namespace default. We have no labels attached, that's fine. And we see an overview about workloads. So we have no deployments and no pods. Okay, pods, we had that. These are the little cute things that are running our containers within our nodes. What are deployments? A deployment is also a concept within Kubernetes, which is a declarative description where you tell Kubernetes how many pods you want and how many replicas you want, or replica sets you want. Within this deployment, which is kind of a logical container, you describe the target state that you want for the stuff that you deploy to Kubernetes. And the controller within the Kubernetes system, the deployment controller, always checks your defined target state versus the state of the cluster. And if both things meet, everything's great. If there is a deviation, the deployment controller will act correspondingly. So for example, if a pod dies and you defined I want one pod running, the deployment controller will spin up another pod. Now, I said the deployment contains pods and replica sets. We will see that later in the sessions when we deploy applications, how we define that. Now, a replica set is another part of Kubernetes. And a replica set basically is intended to keep a certain set of pods available. So it's really a replica of a pod. It's a one-to-one copy in the sense of let's say, horizontal scaling. So it's it contains kind of a blueprint for your pod, so that if your pod dies, this blueprint can be taken in order to spin up another pod. And it also defines how many pods should be available at a given time. Yeah, that's basically it. So deployment is the logical how the logical entity that you deploy to a Kubernetes cluster, and within the deployment you describe how your application looks like, or the target state of your application, which means which containers do you want to put in which pods, and how many pods you want to spin up, and how many replicas you want to have. Okay, that's okay, understood. Now let's see, what do we have here? A service management. Okay, we have a catalog, so probably what we see here are services that are available. Now, service catalog is again a concept of Kubernetes. So within the service catalog, you can display services that are available within your namespace. They come from services or from servers that use the Open Service Broker API. So you do not want to reinvent the wheel when you build an application within Kubernetes. So the concept is you drag in external resources into your Kubernetes cluster and make use of them within your application. And in order to do that in a unified way, you use the servers that support the Open Service Broker API, which is an open standard. And all these services are then displayed here within the service catalog. So here we have several services that are available or made available by default. As you can see, there are SAP services. And we also have the option to hook in services from hyperscalers like AWS, like Azure, or like Google Cloud Platform, as far as those services are backed by Open Service Broker API. So we will take a look at that one also in a session, because I would like to hook in some services from Azure and then use them within our applications. Okay, now the service catalog per se only says that we have additional services that are installed outside of our cluster that we can use, but it's really just kind of a blueprint or a class that you then have to instantiate in order to use them within your application. So this is then here where we can then create service instances. Service instances are then the concrete instance that you can use within your application that is drawn from the blueprint, from the template of the catalog. Yeah, brokers, I mean, we have no service brokers hooked up, except for the ones that are there by default. So that's it from that side. What do we have else? Oh, we have quite some configurations here. Let's see. We have API rules. As we have seen before, we have those nodes. The nodes and the nodes contain the pods, and the pods have some IP address, and we have the kubelet in order to communicate between all the things. But when we deploy something to Kubernetes, nothing will be seen from the outside. It's all running within the cluster. It's addressable within the cluster, but this is not really cool when it comes to, let's say, applications that you want to consume from the outside. And this is where API rules kick in. So they they allow you to define rules, how you want to expose services. So what services do you want to expose? And how you want to make them accessible with respect to authentication. We will see that when we deploy our first application, which will be in the next session. Auth client. Okay, so this is also something. It's not available everywhere. Yeah, it's here, for example. That's really cool in the Kyma dashboard, that you have this documentation here. So you can now jump to the documentation of the corresponding area within the Kyma documentation right from the console. That's something that should really be everywhere possible. I haven't seen it completely strictly within all the Kyma menus, but that's something that I really like. Now OAuth. As we know, there is this OAuth IDP that I think it's ORI exactly. That's part of this opinionated stack of Kyma. Now, if you want to do OAuth authentication, which will also be part of a session that we will do, you have the OAuth server within Kyma. And in order to authenticate against the OAuth server, you need an OAuth client. And for the OAuth client, you need this little menu here. So where you create the client in the namespace in order to access services that are secured via OAuth. Okay. So let's go one step further. What do we have? Permissions. Okay. So we had to assign role bindings in order to access the dashboard, and they are also mapped here to some internal roles. And there are two different types of role bindings within Kubernetes. And you see them already here. So we have roles and we have cluster roles. And as the name already suggests, cluster roles, CRs, as depicted here, are relevant for the whole cluster. So it's independent of the namespace, like this runtime namespace admin role binding, where the role of the namespace Kyma namespace admin is behind. And we have roles. There are no roles in this namespace yet, which are restricted to the specific namespace. So within the namespace, I can then bind rules of both types. Of course, I can do a binding of cluster roles because they are available all over the cluster. And I can also bind roles, but they are specific to the namespace. Okay, also something to keep in mind when it comes to authorization issues. Then we have resources. Okay, that's interesting, and you will not see that right from the start if you just go to the default namespace. What's behind that? We have two things. We have resource quotas and we have limit ranges. As I said, you have underneath Kyma, you have this Kubernetes cluster. And this Kubernetes cluster is a physical cluster. So it has kind of restricted resources. Now, if you think about a company that builds applications on top of Kyma with several teams, then you want to make sure that every team gets its fair share of the resources available within the cluster. And how do you do that? Well, first of all, you will certainly separate the teams in different namespaces. And within the namespaces, you can use the resource quota object of Kubernetes in order to restrict the access on resources. That's kind of the memory, compute, and so on that you have within one namespace, and you can restrict it with the quotas. That's one thing. The next thing is, even within one team, you will, if you do a microservice approach, you will run several microservices. Now, they will run in containers, and by default, Kubernetes does not restrict the access of containers to the resources within the namespace. So if you have 5 microservices and one consumes all the resources that are given to your namespace, the other 4 microservices are probably not that happy. And the same goes for the developers that are developing these other 4 microservices. So with the limit range, you can set a limit to the in Kyma to the memory consumption of your containers. So let's go one step back to see where this comes in. So we have here the default namespace. We can add a new namespace. We can add a name here. We can add a label. This is something that I will talk about in a later session. And here we can apply a total memory quota, which means I have this resource thingy, and restricted to memory limit and memory request. And I can apply limits per container that are depicted here. So this is kind of the way to restrict the access to your containers and your memory. I have not yet, to be honest, worked with that stuff, so I have no idea what's the best way to define that, but that's definitely something, if you start working with several teams on a Kyma cluster, something that you should think about. Then we have config maps. Now, config maps is also an interesting part of Kubernetes. These are maps that define configurations that live outside of your containers and that you can use within your containers like environment variables. So this way you decouple configuration from code, which gives you more flexibility. And the container that is running can then fetch this configuration at runtime, which makes it quite easy, or makes it more comfortable to make your containers portable, because you do not rely on any specific configuration within the container. You just drag in the right configuration from outside the container. Now, why do we have some default config maps here? From my perspective, that's due to the fact that we have this serverless part, this Knative part within Kyma, where you put in some code, as we will see in a second, and this code has to be put into a container and then has to be run. These are kind of the things then that back up this development from my perspective, but you can also put in other config maps during deployment in order to make them accessible. Okay, so we have services. We can do a lot of configuration around security in the broadest sense, around operational constraints. Now we can also do a bit of development within Kyma when it comes to functions. This is, I think, I planned it as the fourth session, if I remember correctly, where we will use this little thing called functions. So functions as a service that live on top of Kubernetes, scale to 0, and so on and so forth. So they have all the qualities that you would expect from functions as a service. And they can be triggered by incoming and requests, events, and you can also expose them as endpoints outside of your cluster via API routes. This is something that we will definitely take a look at. And now let's go to the last part. We have operations. Now we already have talked a bit about that. We have deployments. Okay, that was the thing, the declarative description of a target state. So if we deploy something, it should be here. Okay, let's see. In the next session, we will deploy an application. Let's see what we find here. And we have replica sets. That was one part of a deployment, as well as pods, where we define kind of the blueprint for our pods and how many replicas, copies we want to keep. We have pods. We don't have pods because we do not have yet deployed something, which are the atoms of the Kubernetes. Okay, we have the services. Okay, the services, that's interesting. That seems to be that there are some default services within Kyma running. So a service is something different than a service instance that we saw before. These services here are another, again, a construct of Kubernetes and an abstract way to make services available on a set of pods. So like this Kubernetes service, which is the basic service overall that you need in order to have the interaction within Kubernetes. And here this service is exposed so that all the things can talk to each other. As you can see, we have one internal cluster IP, we have internal endpoints. And as you also see, we have these labels in order to keep them accessible, findable within traces. Okay, so let's see how these things evolve when we deploy an application. And last but not least, we have secrets. There are quite some of them. So this is really the secret store within Kubernetes. So we have, as we see, different types of secrets that can be stored here that are of different types. And these are really secrets in the truest sense. So you do not store your secrets within your container. At least you should not do that. You can do that, but that's basically one of the not so good ideas. And here we have several secrets that come by default. So we have Kubernetes service account token, so a type of account token, which is typed by the default Kubernetes. We have Docker configs, we have basic auth for the serverless registry credentials. Again, we have a service account token for something in the serverless area. And we have additional secrets that are also typed, but that come from different components. So as we see here, this is a key insert type of secret that is used by Istio, by the service mesh. Okay, so boom. Quite some stuff for the first session to get an overview about Kyma, but that was to expect with respect to the stack that is within Kyma. So we have also a lot of options or things that we can find out here about operations with deployments, replica sets, pods. We have the services that are these abstract network services, or a way to abstract app services in order to be accessible over the network within the cluster. And we have secrets. Okay, so yeah, I will call it a day then for today. So we have now set up our Kyma environment. We have brought in all the necessary roles in order to access Kyma. We have learned that the Kyma UI is quite fast because there is a really interesting micro front-end UI living behind this UI. And we have learned a lot about Kubernetes and the, let's say, objects and resources that come along with Kubernetes or with Kyma. So as a cliffhanger, what will we do next time? next time we will do a deployment and see what happens within all these resources when we have done the deployment, and how we have to do, or what we have to do in order to make a deployment. So with that, I say goodbye and until next time.